helicopter circles a burning mountain of rock. Below, a line of trucks coils up the black slope like a metal serpent, headlights cutting through ash. One by one, they tip their cargo over the edge. Entire cities worth of plastic, metal, food waste, electronics, all swallowed by orange, boiling lava. The air trembles, the crater roars, and in a single violent breath, the volcano turns our trash into smoke. Now imagine this is not an experiment. It's global policy. From today on, every piece of garbage humanity produces is destined for fire from the center of the earth. If you like understanding the world from angles no one else ever explains, subscribe. Here, every what if is taken to its ultimate consequences, with logic, data, and both feet firmly on reality. We start from a simple truth. The planet is drowning in waste. Every year, humanity produces over 2 billion tons of municipal solid trash, and that number is still climbing. Landfills expand like slow-motion wounds on satellite images. Rivers become conveyor belts of plastic, heading toward the sea. Microplastics are now in our lungs, our blood, our food. For many people, the waste crisis feels distant, hidden behind fences and euphemisms like sanitary landfill or waste management facility. Then the idea appears, half joke, half desperation. Why don't we just throw it all into volcanoes? Lava is hot. Trash burns. The Earth is already venting heat and gases. Instead of piling waste on the surface, we return it to the planet. It sounds bold, clean, final. Politicians under pressure love solutions that sound final. A charismatic leader somewhere puts it on the table not as a meme, but as a proposal. Task forces are formed, diagrams appear. Suddenly, the question that used to live only in late-night conversations and internet threads is being studied by ministers, engineers, and risk committees. The moment everything changes is not when the first bag of trash hits the lava. It's when the world decides that waste is no longer a problem of land, oceans, or recycling, but of fire. From that day on, the map of the world is redrawn around a single dangerous asset: active volcanoes. And this is only the surface of what that decision really means. Because if we're going to use volcanoes as garbage disposals, we need rules. The Earth has more than 1,500 potentially active volcanoes, not counting those hidden on the ocean floor. Only a fraction of them erupt frequently, and an even smaller fraction is remotely accessible by road, sea, or air. The first rule appears immediately. Not every volcano is usable. Engineers classify candidate volcanoes like infrastructure: high access, low risk; remote, high risk; no-go. You can't fly cargo planes over exploding craters. You can't build highways across tectonic minefields without expecting them to crack. So the world quietly converges on a short list. A few dozen volcanoes in politically stable regions, with roads, ports, or flatland nearby. These become humanity's unofficial dumpsters. Second rule: waste has to move. That means trains of compacted trash crossing continents, convoys of trucks from megacities to volcano hubs, specialized cargo ships rerouted not to ports near factories and consumers, but to coastlines close to subduction zones and volcanic arcs. The energy cost is enormous. Every kilometer adds fuel burned just to position waste to be burned again. Third rule: not everything can just be thrown in as is. Certain materials explode when suddenly heated. Pressurized containers, batteries, some chemicals, they become shrapnel inside the crater. So we add pre-processing plants near volcanoes. Trash is sorted, shredded, compacted, sometimes partially incinerated before it even meets the lava. We have, ironically, rebuilt the waste system we already had, just closer to the crater. Fourth rule, emissions. A volcano is not a magic hole. Anything we throw in is either buried in molten rock for a while, or turned into gases and particulates that escape into the atmosphere. Plastics become CO2, carbon monoxide, dioxins, and a long list of toxic compounds. Electronics mix heavy metals with volcanic gases. Organic waste produces additional greenhouse gases on top of what the magma already releases. Our solution simply trades land and sea pollution for a concentrated, violent form of atmospheric pollution. Fifth rule, proximity and sacrifice. You can't do this from a safe distance. Someone has to live near these volcanoes. Someone has to breathe this air. So, quietly, a political pattern emerges. Richer countries pay poorer, volcanically active nations to host global waste craters. Trash colonialism wearing a high-tech mask. On paper, the rules make the system look controlled. In reality, they only set the stage for pressure to build. The first years feel like a demonstration era. Governments want proof the system works. Media outlets broadcast live as the inaugural global waste convoy winds its way up the side of a shield volcano under strict scientific monitoring. The narrator on TV says what everyone wants to hear. The lava is so hot it instantly vaporizes the waste. Nothing remains. Except that's not quite true. Lava is hot, often over 1,000 degrees Celsius, but it doesn't act like an industrial incinerator designed for clean combustion. A truck backs up too close. The rear gate opens. Compressed bales of trash tumble down into the crater. Some of it burns, some of it does not. Some rides thermal currents back up as glowing debris. The first surprise is smell. Not the sulfur egg odor of volcanic gases people expect, but the acrid synthetic stench of burning plastic and chemical compounds. A gray-brown haze hugs the ground on the leeward side of the volcano. Nearby villages report headaches, coughing, irritated eyes. Kids stop playing outside. Cattle refuse to graze. Then comes the first accident. A load of mixed waste containing sealed containers and pressurized cylinders hits a partially cooled lava shelf. The sudden heating causes them to rupture explosively, fragmenting molten crust and hurling burning debris back toward the access road. No one dies, but the footage of trucks reversing under a rain of fiery projectiles circulates the world. Scientists publish the first independent measurements. The trash volcano emits not only its usual mix of water vapor, CO2, sulfur dioxide, and ash, but now traces of chlorine compounds, fluorinated gases, and heavy metal-laced particulates, not normally seen at those levels in volcanic plumes. Local rainfall starts showing contamination. Crops downwind begin to fail. Yet, at the same time, a different kind of number is celebrated, a sharp drop in the volume of landfilled waste. Satellite images show closed dumps. Coastlines once lined with informal trash piles look cleaner. Politicians point to before and after photos. They declare the experiment a tentative success. They don't mention that the system is still running on a small scale. Only a fraction of the world's 2+ billion tons of waste is reaching volcanoes. The promise is that, soon, all of it will. That's when the real phase of the experiment begins, and when everything starts to unravel. Because the second wave is not scientific, it's economic. Once the infrastructure exists, there's pressure to maximize its use. Contracts for waste shipping become billion-dollar industries. Volcano-hosting countries negotiate long-term deals. Corporations build entire business models around deep earth disposal. Waste streams that were once partially recycled Metals, some plastics, even paper, now face a brutal economic calculation. Why spend money to separate and recover them if dumping into a volcano is cheaper per ton? Even small price differences steer millions of tons of material toward lava. Globally, recycling rates begin to fall. At the same time, the scale increases. Multiple volcanoes are now active waste sinks. Each receives trains, trucks, and ships daily, feeding them like roaring furnaces. To people who live far away, the system is invisible. To those nearby, it is a permanent thunder in the background of life. The cumulative effect on air quality becomes impossible to hide. Volcanic plumes enriched with industrial byproducts travel thousands of kilometers. They interact with clouds, with jet streams, with urban smog. Flights detour to avoid abrasive ash and corrosive gases. Hospitals in downwind regions quietly record rises in respiratory and cardiovascular conditions. And volcanologists start to notice something else: the thermal and mechanical disturbance inside the craters. Every heavy load alters local stress. Every rapid quench of lava by sudden cold materials affects the crust. No, we are not turning volcanoes on by throwing in trash, but we are adding noise to already unstable systems. In a few places, this noise matters. One mid-sized stratovolcano, heavily used due to its road access and relative calm, begins to show unusual behavior. Changes in gas composition, micro-earthquakes at shallow depth, deformation of the crater floor. At first, it is chalked up to normal variability, but the monitoring data forms a pattern. The spikes correlate with peak waste delivery days. Warnings are issued. They compete for attention with quarterly revenue reports from companies whose profits depend on not slowing down the flow. The world believes it's found a way to make trash vanish. It's about to learn what happens when you treat geological monsters as household appliances. The breaking point arrives on an ordinary day. Trucks climb, ships unload, conveyor belts feed compacted waste into the mouth of a volcano that has been treated like a bottomless pit for years. The sky is clear. The sensors are not. For weeks, magma had been slowly rising inside the mountain, pressurizing the system. Internally, the volcano was approaching a threshold. The additional weight of waste is trivial compared to the mass of rock and magma, but the physical disturbances, vibrations, thermal shocks, surface collapses, have been steadily chipping away at the stability of the crater floor. That morning, a segment of overhanging, cooled lava loaded with embedded trash fails catastrophically. It collapses into a conduit already full of gas-rich magma. Superheated water locked in some of the waste flashes to steam. The interaction is violent. What had been building as a moderate eruption becomes something far more explosive. Seismic stations light up. There is no time for a gradual escalation in alert level. The mountain tears itself open. A column of ash, gas, and pulverized rock punches into the sky, loaded with fragments of everything we have been feeding it. Metal, glass, plastic beads, chemical residues. Pyroclastic flows pour down valleys that, until recently, were truck routes and worker housing. Thousands of people are in the impact zone. Drivers, plant workers, families in towns that were told this was safe enough. The human cost is immediate and raw, but the catastrophe does not stay local. The ash cloud spreads across borders, into flight paths, over agricultural regions, across densely populated areas. It takes days just to understand what is in that cloud. For a brief moment, global emissions from waste actually dip. Ports close, convoys halt. Every trash volcano project on Earth is frozen by emergency decrees. Governments convene emergency panels that look disturbingly similar to the ones that approved the program years earlier. Except now, the graphs show something else, a form of risk that people refuse to factor in, the fusion of industrial waste and geological hazard into a single amplified threat. What began as a clever idea to make trash go away has become a source of new disasters. And the worst part is this: even if we stop now, the consequences won't vanish with the last truck. The damage has momentum. The global waste volcano boom leaves a long, dirty wake. Countries that hosted these craters now face contaminated soils, damaged water sources, and populations traumatized by years of living next to engineered hell. Monitoring data shows persistent anomalies in gas emissions. Trace pollutants continue to leak from modified lava fields. Some craters, partially filled with solidified, trash-rich rock, become unstable overhangs and landslide risks. Geopolitically, trust is shattered. Nations that exported their waste under glossy sustainability contracts are accused of having knowingly outsourced both pollution and risk. Civil movements demand reparations. International courts hear cases not just about toxic dumping, but about geological interference. Economically, entire industries that grew fat on easy disposal collapse fast. Jobs evaporate. Some former volcano hubs try to pivot to tourism or geothermal energy, but their reputation as sacrifice zones keeps investors away. Property values around these sites stay depressed for generations. Environmentally, the atmosphere remembers. The concentrated burning of complex waste streams in open volcanic systems has added a distinct signature to air, soil, and ice records. Future scientists will be able to point to layers in glaciers and sediments and say, "This is the era when humans tried to solve their trash problem with volcanoes." Culturally, the experiment changes how people think about waste. For a while, there was a dangerous illusion that trash was something you could simply delete with enough heat. After the catastrophe, that illusion is gone. But so is something else. The old excuse that we didn't know any better. We did. We chose to ignore what the physics and chemistry were saying. By the time the last waste conveyor is dismantled, humanity has paid twice, once in money, once in consequences. And still, the core question remains on the table, unchanged and staring back at us. So what would really happen if we tried to throw all the world's trash into volcanoes? First, logistically, it would barely work. We generate billions of tons of waste every year. Only a tiny fraction of active volcanoes are accessible or stable enough to even attempt this. The cost, energy use, and infrastructure needed to move that much material to those few sites would be astronomical. Second, environmentally, we would be swapping one crisis for another. Landfills, oceans, and rivers are horrifying, yes, but using volcanoes as giant open incinerators would supercharge atmospheric pollution, spreading toxic compounds globally with almost no way to control their dispersion. The idea that lava destroys waste ignores a simple reality. Matter doesn't disappear. It changes form. Much of what we'd throw away would become gases and microscopic particles entering our bodies, our climate, and our food chain. Third, geologically, we would be deliberately disturbing some of the most powerful and least predictable systems on Earth. The mass of trash is tiny compared to mountains of rock, but the way we deliver it, in pulses, with chemical surprises, onto structurally delicate surfaces, can add failure points to systems already close to the edge. The probability of directly triggering a super-eruption is extremely low. The probability of amplifying local hazards and making eruptions more dangerous for the people nearby is high. Fourth, psychologically, this solution would attack the problem from the wrong end. Instead of forcing us to reduce, redesign, and reuse materials, it would encourage more consumption under the illusion of infinite disposal. The real secret here is uncomfortable. Our waste crisis is not primarily a "where do we put it" problem. It's a "why are we producing so much in the first place" problem. Volcano dumping would delay that confrontation, not solve it. In the most plausible outcome, after some years or decades of partial implementation and growing evidence of harm, the world would abandon the project. Not because we suddenly became wiser, but because reality, health data, air measurements, eruptions, accidents, costs, made the experiment untenable. We would be forced back to the same place we started, except poorer, more damaged, and with even less room for error. This is the part that almost no one mentions when the idea pops up as an easy fix. The Earth does not offer shortcuts, especially not ones that involve waking up its deepest forces just to hide our mess. In the end, the most realistic answer to "why don't we throw our trash into volcanoes" is brutally simple. Because it would make almost everything worse. For the air, for the climate, for the people who live near those mountains, and, paradoxically, even for our ability to deal with waste in the long term. The real work has to happen before the trash exists, not at the edge of a crater. So imagine, one last time, that helicopter circling the burning mountain. The trucks have stopped. The road is empty. The volcano still breathes, indifferent, venting steam and gases into the sky like it has for thousands of years before us, and will for thousands after. The only thing that changed in this scenario was us, our decision to see it as a cosmic trash can instead of what it truly is. A reminder that the planet plays with forces on a scale we should respect, not try to use as shortcuts. The question that remains is not, why don't we throw our trash into volcanoes, but what does it say about us that we wanted to? And if you were in the room when this idea came up for real, would you vote to light that fuse, or to finally face the mountain of waste we've built on the surface in full daylight, where the real problem has always been?